Hey lead teachers, please take notes over the next 4 slides. You will be teaching your group on Wednesday, so please make sure you understand all 4 slides. If you have any questions, you can come to tutoring on Tuesday morning or after school to get more assistance. Or also, there will be a test on Wednesday over the 4 slides, and if your group does good, remember your incentives. Okay, so now let's look at the first slide. Function. Remember the definition of a function. A function is every x value has only one y value, or x does not repeat. Okay, so remember the definition of a function. Make sure you write this down so you can tell your group members, so at least they have it. So let's look at the first example. We have a. If we look, we're only looking at the x values because the x values cannot repeat. Okay, x does not repeat itself. So let's look at our x. We have 3, negative 2, uh-oh, messed up. Okay, I have negative 2, and I have 0. So, right here, since x repeats and has different y values, it is not a function. Okay? Since x repeats and has different y values, it is not a function. Okay? Let's look at the next example. We have 3, 4, negative 2, and 0. Again, we're just looking at the x values. Now, since x does not repeat, then this is a function. Okay? X did not repeat because we have 3, 4, negative 2, and 0. None of those repeat, so it is a function. Now, let's look at function notation. Function notation, the example we have. A quadratic function is given below. F of x equals 3x squared minus x plus 6. What is f of negative 3? Well, remember, this is the same as f of x. Okay, so negative 3 is in the same place as x. So for every x value up here, we're going to plug in negative 3. Okay, remember, everyone else stays out there. So when I write this, I'm going to have 3 parentheses because I'm substituting in, and I'm going to substitute in negative 3 for my x. Okay, so there's where my negative 3 came in. Squared minus, and then parentheses because I'm substituting in again for x. Negative 3 plus 6. Okay, now then you would just put this in the calculator, and when you put it in the calculator, you would get, okay, so you would get 36. Now, when you plug this in the calculator, you would plug it in just how it looks. So you'd plug this in just how it looks, parentheses and all. You notice how this square is on the outside of the parentheses. When I put it in the calculator, it has to be on the outside of the parentheses. Okay? Just how it looks. And we always use parentheses when we're substituting in. Okay? Now, let's look at independent and dependent. Our example says, when filling up a pool at a rate of 10 gallons per minute, the relationship between volume of the pool, V, and the time spent filling the pool, T, is described by the function V equals T10, 10T, Which statement is true? So we want to look to see which statement is true. Anytime it's asking for independent and dependent, we're always going to look at the equation. So you're going to take your equation. Now, the way that I know that this is independent and dependent is because in my answer choices, it says depends on. And now right there tells me I'm talking about independent and dependent. So something's going to depend on something else. Now, let's shy away for a second from this problem, and let's just talk about independent and dependent. Independent, remember, is your x values, and dependent is your y values. Okay? Always remember this statement. Y depends on x. Okay? So y is always going to depend on x. So now let's go back to this equation, and we're going to take our equation up here, and we're going to turn it into y equals. So it would be y equals 10x. Now, you look to see what is in place of what. So, y took the place of v, so we know that v depends on and then x took the place of t, so it depends on t. And now just substitute in the words for it. Volume, because v represented volume, depends on time. So which answer choice tells me volume depends on time? A, volume depends on time. So my answer is A. So always take your equation, substitute it into y and x, and then remember that y always depends on x. Okay, now let's look at the last one. We have inverse functions. Remember, the equation for an inverse function is x times y equals k. Okay, and remember that k is the number that is constant in the table. So k is going to be that constant that's in the table. And remember, constant means the same. So it's never going to change. Okay? So you're going to take your x and you're going to multiply it by your y. So up here, if I take 2 and I multiply it by 6, I get 12. If I take 3 and I multiply it by 9, I get 18. If I take 18 and I multiply it by 6, I get 108. Now, if we look, k changed. So k is not constant, so this is not a inverse. Okay, it's not an inverse because none of my k values are the same. All my k values must be the same. So let's look at the next example. We have 1 times 8, which is 8. We have 2 times 4, which is 8. And we have 4 times 2, which is 8. Since they are all the same, this is an inverse. Since all my k values are the same, when I multiplied x times y, it is an inverse function. Okay? Okay, so if you have any questions, please bring them to tutoring. If not, be prepared to teach your class on Wednesday. And don't forget about your incentive if your kids do better. Have a wonderful evening. Goodbye.